Let's look at an example of adding and subtracting complex numbers. So in the previous video we talked about complex numbers that consists of a real pod, a real number, and an imaginary number. So let's say we've got two complex numbers, u and v, and we want to add these two complex numbers. So doing addition with complex numbers works the same as doing additions with normal algebra. So what we do is we see the I for the imaginary number as a variable. So if we say what is u, so this is u plus v, we add the similar numbers together. So we'll see that the 3 and the minus 2 is real numbers. They are real numbers, and we've got imaginary numbers, the plus 2i and minus 3i. So if we add the two complex numbers, we do a 3 plus a 3 minus 2, and we want to also take the plus 2 minus 3 for the I. So 3 minus 2 is 1, and 2 minus 3i is minus I. So if we add these two complex numbers, we get 1 minus I. If we do subtraction, we do exactly the same. We're going to say subtract. We're going to say u, which is 3 plus 2i, and we subtract the v, which is minus 2 minus 3i. So with normal arithmetic, we'll say that this is plus 2 plus 3i, and the answer then of the similar number in this case would be 3 and 2 and plus 2i and 3i. So if we add this together, we get 5 and plus 5i. Add these two together. So similar to adding and subtracting, we can also do multiply. So let's multiply u with v. Again, it works the same as normal algebra. So we want to multiply these two brackets. And like normal algebra, we have to multiply each of the terms in the one bracket with all the other terms in the other bracket. So we have to do this multiplication. So in this case, we will say 3 times minus 2 is minus 6. 3 times minus 3i is minus 9i. 2i times minus 2 is minus 4i. And 2i multiplied by minus 3i is minus 6i squared. So up to now, it's similar to what we do with normal algebra. So we can add these two together. So the only change or additional calculation that we have to do is the minus 6i squared. So we know from the previous video that I squared is equal to minus 1. So minus 6i squared would be minus 6 multiplied by minus 1, which is plus 6. So this will be plus 6. And then we're going to have 6 minus 6 plus 6 is 0. And minus 9i minus 4i is minus 13i. Or just minus 13i. What we can also do is we can say, for instance, what is 3 multiplied by 3 plus 2i, and just like the previous slide, you will see that we can just multiply this in, and we'll say 3 times 1, 3 times 3. We say 3 times 3, and we have to multiply the 3 times plus 2 as well. So we get 9 plus 6i, would be the answer there. So there's one special case of multiplication that we will use with division, but we can just talk about this quickly, and that's the conjugate of a specific complex number. So if we've got a complex number, let's say minus 2i plus 3i, the conjugate of this, depicted by a little star, would be minus 2 minus 3i. So you can see this is the conjugate. The conjugate of v is depicted with this little star there. You'll see it's exactly the same real number and it's the same imaginary number, except that the sign of the conjugate is the opposite. So you can see that it was plus 3i and it's minus 3i. So there's a very important property that we get when we multiply the complex number with its conjugate. So let's see what happens. Minus 2 plus 3i, minus 2 minus 3i. So if we multiply this, we use the same rule as we've looked at now. So we have to multiply the first term with both terms and the second term with both terms. So if we look at this, we'll get 4 minus 6i, plus 6i, minus 2 minus 3 is plus 6, and then minus 6i, that's 3i multiplied by minus 2, and then minus 9i squared. So you'll see the middle term, so this is almost like difference of squares, so difference of similar terms. So you'll see it's exactly the same terms except the sign is different. So you'll see the middle term always cancels out. So 6i minus 6i is 0. And then remember the minus 9i squared would be minus 9 multiplied by minus 1. And that would be plus 9. Plus 9. And answer would be 13. So you can see when you multiply a complex number with its conjugate, there is no imaginary part left. So the answer would always be a real number. So that's important going forward. So what we've covered here is the addition, subtraction, and multiplication of complex numbers.